We now do question 1. Here in this question, we are given that the area grows at a rate of 2 centimeter cube per second. So here I have represented this dA over dt equals 2 centimeter per cube, where A represents the area of the circle, and we have to determine the rate at which the radius grows when radius equals 10 centimeter. So basically, we have to find this value of this expression, that is dr over dt. So let's see how to do this one. First, let me consider the area of the circle. That is, area of the circle is given by the formula A equals pi r square. Now I differentiate both sides with respect to time. So the rate of change of area, which is written as dA over dt. When you differentiate A with respect to time, we get dA over dt, and this equals pi is a constant, so we just put this as it is, and we have to apply the power rule as well as the chain rule to differentiate r squared. So when we apply the power rule, we get 2r, and then we have to differentiate r with respect to time. That is, we write down dr over dt. Now we can substitute the values of dA over dt as well as r equal to 10 centimeter into this equation to solve for this quantity dr over dt. So let's do that. I'm going to plug in dA over dt equal to 2, and this equals, this is 2 pi r. I can substitute for r, which is 10 centimeter. So I put 10 times of dr over dt. We see that we have the factor 2 on both sides, so we can simply cancel them, or we can consider that if you divide both sides by 2, these two will get cancelled, so we will have 1 on this side. Now we have to solve for dr over dt, that is dr over dt, and this equals, we have 1 over, we have to divide by this quantity 10 pi, so it becomes 1 over 10 pi. And when we put this into the calculator, approximately we get 0.032, and the unit of this rate is centimeter per second. So therefore we say that the rate of change of radius is 0.032 centimeter per second. Let's do question 2. Here we have a square pyramid whose length and width are equals x, and the height is always the half the length. So I can write down the expression for height, which equals half the length. Since x represents the length, this will be x by 2. And we are also given the length grows at a rate of 2 inches per minute, and we have to determine the rate at which the volume grows when x equal to 3 inches. So let's see how to do this one. First, I'm going to use the volume of a square pyramid using this formula. That is, I write down volume equals s squared times h over 3, where s represents the base side length. So here the base side length is x. I can replace and rewrite this formula as x squared times h is basically the height of the square pyramid. We determine the height of the square pyramid is x by 2. So I'm going to replace this by x by 2, and this is divided by 3. So let's simplify this. So we have the volume formula, that is V equal x squared times x by 2, and I can put this divide by 2 as I'm sorry, divide by 3 as 1 by 3. So we can simplify this further, that is x squared times x is x cube, and 2 times 3 is 6. So basically we get the expression for volume as V equals x cube by 6. Now let's differentiate both sides with respect to time. So differentiation of V with respect to time is dV over dt, and this equals, I can put this as 1 by 6, which is a constant, which we will not have to differentiate if we use the constant multiple rule. And then we have to differentiate only the x cube. The differentiation of x cube is 3x squared, and then we have to apply the chain rule to differentiate the x with respect to time. So we will get dx over dt. Let me put this here, that is 3x squared times dx over dt. So this is the derivative of x cube. Now we can plug in the values. We know that x equal to 3 inches, So we plug in x equal to 3. In fact, we can cancel this 6 with the 3 as it goes 2 times. So this basically equals 1 by 2 x squared. I'm going to replace x as 3. So therefore this becomes 3 squared. And we are also given the dx over dt. So this information basically represents dx over dt. That is the rate of change of length, which is growing at a rate of 2 inches per minute. So we can consider dx over dt equals 2. So let me plug in 2 for dx over dt. We see that this 2 and this 2 gets cancelled. So basically we get 9 squared. That is the volume changes at a rate of 9. I'm sorry, it is 3 square is 9. So this equals 9. And we put the unit, that is this has to be in cubic units per unit of time. So it is inch cube over, uh, and the unit of time here is minute. So this is the one which represents the rate at which the volume changes. It changes at a rate of 9 inch cube per minute. Let's do question 3. So here in this question, we are given that a snowball melts so that its surface area decreases at a rate of 3 centimeters square per minute. So if S represents the surface area of the snowball, a snowball is basically spherical. So we can consider that this is a sphere. So if S represents the surface area of the sphere, then we write down its rate, that is ds over dt. And since it is decreasing, I have put this as negative 3 centimeters per minute. So I have written ds over dt equals negative 3 centimeters squared per minute, which represents the rate at which the surface area changes. And we have to determine the rate of change of radius when r equals 5 centimeter. So let's see how to do this one. First, I write the surface area formula for a sphere. That is, a surface area is given by S equals pi times of r square. I'm sorry, it is 4 pi r squared. Now we differentiate both sides with respect to time. So the differentiation of S with respect to time is ds over dt, and this equals, we have to differentiate this right side. Here we have 4 pi, which is a constant, and then we have to differentiate only this r squared with respect to time. So first we use the power rule, and when we do that we get 2r, and then we have to differentiate r with respect to time, and this equals dr over dt. So we put dr over dt. Now we can substitute the values which is given over here. ds over dt is negative 3. So I put negative 3, and this equals, this is 4 pi times 2 is 8 pi, and then we have to multiply with the radius. So we take this radius, that is 5 centimeter. So I put 5 here, and then we have to determine dr over dt. So let's solve for dr over dt from this equation. And if we find it, we get dr over dt, and this equals, we have negative 3 on one of the side. So this negative 3 divided by this multiplier in the dr over dt, that is 8 pi times 5 is basically a 40 pi. So we can put this expression into the calculator, and when we do that, we approximately get negative 0.024, and this is rounded to 3 decimal places. And we also put its unit, that is a centimeter per minute. So we see that the radius is changing at a rate of 0.024 centimeter per minute. Otherwise, we see that the radius decreases at a rate of 0.024 centimeter per minute.